So this is a question for superposition theorem. Here you can observe that E1 is 60 and having some resistance 0.5 ohms, and this is R1, R2 and R3 resistance as 24 ohms, 10 ohms and 12 ohms, and this is one source E2 which is having 48 volts. So for this network we need to apply superposition theorem. So you already know the statement of superposition theorem. So now we'll solve the problem according to the rules and regulations which we have to follow in solving this superposition theorem. So first what you have to do means you have to redraw this figure. So here it has been given that this is having 60 volts, 0.5 ohms. That means that it is having some internal resistance of value 0.5 ohms. Now let us draw this circuit and then solve by applying superposition theorem. So now the figure has been redrawn. So the internal resistance, whatever it is 0.5 it has been given, we have taken that into consideration, that is 0.5 ohms. 24 ohms, 10 ohms, 12 ohms, and this is 48 volts and this is 60 volts. Now what we have to do means we have to first denote the nodes. We have denoted the nodes as A, B, C, D, E and F, and we have also denoted the internal resistance. So from this diagram you can observe that 0.5 ohms and 24 ohms are connected in series. So simply we can add these two resistance, then what happens, the resultant becomes as 24.5 ohms and remaining as it is 10 ohms and 12 ohms. This is 48 volts, this is 60 volts, and these are nodes A, B, C, D, E and F. Now for this circuit we need to apply superposition theorem. So whenever you are applying some superposition theorem, first step is nothing but you have to consider only single source, either voltage source or current source, and remaining all other source should be not considered. That is, if there is a voltage source you have to short circuit, if there is a current source you have to open circuit. Now what we'll consider means we'll consider only 60 volts voltage source and this 48 volts let us short circuit, and after that we have to denote the current directions. Now we have to change this resultant circuit by indicating the current directions and considering only 60 volt voltage source and making 48 volts as short circuit. Now the figure has to be redrawn and then we have to apply the superposition theorem. So now this is the circuit which is considered as step 1, considering only 60 volt voltage source alone and remaining whatever the voltage sources are there, that has been short circuited. So in the given figure what we had here, we have 48 volts. So this 48 volts has become short circuit. And now we have to consider the currents in each branch. The current flowing in this branch let us consider as I1 dash, current flowing in this branch is I2 dash, and current flowing through this branch is I3 dash. So at this point B, what is happening, I1 dash is entering and at this point I2 dash is leaving, and the resultant current flowing in this branch is I3 dash. So for this step 1 we need to find out I1 dash, I2 dash and I3 dash. So you can follow here KVL or else you can follow simply the procedure what I am telling. So first let us find I1, next I2 dash and next I3 dash. So for finding out I1 dash, that is I1 dash equals to current, you know current formula I equals to V by R. So I1 dash is flowing with respect to the current of 60 volts. So let us represent that is V1. Simply first let us represent V1, and next let us see these two resistances, how these two resistances are connected. I equals to V by R, right, formula. So we got V, then we have to find out the resultant R. So here you can find out 10 ohms and 12 ohms both are connected in parallel, right? These two are connected in parallel. So which two resistance are connected in parallel? So if you simply make this resistance connected between these two terminals, you can see this both will be in parallel. So how means like this, let us redraw this. So after redrawing this circuit, this resistance can also be placed between these two terminals, right? This is short circuit means simply this resistor is connected to E itself. So now how these two resistors are connected, they both are connected in parallel. So what happens, I equals to I1 dash equals to voltage I am taking as V1 divided by R2 and R3 are connected in parallel. So what is the formula for two resistance connected in parallel? R2 R3 divided by R2 plus R3 plus these two are connected in parallel. For this two, this 24.5 ohms is in series. So this is R1. So plus R1. So now carefully listen to this formula. I1 dash equals to I equals to formula is current formula is I equals to V by R. So I1 dash is flowing with respect to some voltage, so that is 60 volts. Let us simply consider as V1 divided by these two resistance. How they are connected? These two are connected in parallel. So R2 R3 divided by R2 plus R3 plus the resultant resistor 24.5 ohms will be in series. If you solve these two, what happens? You'll get some resultant. Our resultant resistance will be in series with that. So simply I'm adding plus R1. Now substitute all the values in this formula, you'll get I1 dash. So now I have substituted voltage value V1 equals to 60 volts divided by R2 R3 is 12 into 10 divided by 10 plus 12 plus the total R1 resistance, that is 24.5, that is equals to, if you solve this, you got I1 equals to 2.003 amperes. Similarly, you have to find out I2 dash. So I2 dash equals to, I2 dash. So what is I2 dash? This is the current flowing through 10 ohm resistance. So we need to find out I2 dash. So here we do not have any voltage. So how you have to find out I2 dash? You have to remember the formulas of solving the currents in parallel circuits. So that formula I am writing. I2 dash equals to total current. So here total current I is nothing but what is the initial current? That is I1 dash. So I1 dash into the opposite resistance for 10. So 10 ohms, the opposite resistance is 12 ohms. 12 divided by total resistance 10 plus 12. So how you have to find out I2 dash means I2 dash equals to the total current in the circuit is I1 dash. So I1 dash into the I2 dash current in which it is flowing 10 ohms. So 10 ohms opposite resistance is 12. So the I2 dash is flowing in 10 ohms, right? So I2 dash current is flowing through 10 ohms. So total current I1 dash into the opposite resistance of 10 is 12. So 12 divided by total resistance R2 plus R3, that is 10 plus 12. So if you solve that, equals to how much? What is I1 dash? 2.003 into 12 divided by 10 plus 12. If you solve this, you'll get some current as I2 dash equals to 1.107 amperes. So now you got I1 dash and I2 dash. So you have to find out I3 dash. So I3 dash simply equals to I3 dash equals to what is I3 dash? I3 dash is a current flowing in R3. So what is I3 dash? How we can write? I1 dash current is entering and I2 dash current is leaving. So simply you can write as I3 dash equals to I1 dash minus I2 dash, because I1 dash is entering current and I2 dash is leaving current. So what is I1 dash? 2.003 minus 1.107. If you solve this, you will get something as resultant as 0.896 amperes. So this is I3 dash. So you got I1 dash, I2 dash and I3 dash. Now simply again remember how to solve this I1 dash. I1 dash equals to the current flowing in this R1 resistance. So I1 dash equals to I equals to V by R formula. So we have considered this voltage as 60 volts divided by the resistance of the total circuit, that is R2 R3 are in parallel, because if you redraw it will be in both in parallel. So R2 R3 divided by R2 plus R3 plus the remaining resistance, that is 24.5. If you solve that, you will get I1 dash as 2.003 amps. Similarly I2 dash. So I2 dash is the resultant current flowing in R2 ohms, that is R3. R2. This is R2 and this is R3. So in R2, so current for flowing in this 10 ohm resistance, how you can find out means total current, that is I1 dash into the opposite of 10 ohms is 12 ohms divided by total resistance 10 plus 12. If you solve this, you got this one. How you have to find out I3 dash? That is I3 dash equals to I1 is entering and I2 dash is leaving. So I1 dash minus I2 dash, you got it as 0.896 amperes. So this is your step 1, considering only 60 volt acting alone and 48 volts is short circuited. Now we have to go for second step. Now we'll see step 2. So in step 2, what we have considered, 60 volt is a short circuit and 48 volt acting alone. So you have to consider in step 1 as only one voltage source acting alone and other voltage source should be short circuit. We have found I1 dash, I2 dash and I3 dash. Now in step 2, what we are doing, we have short circuited this 60 volts and considered only this 48 volts alone. So this value is 0.5 volts. So these two are connected in series. So resultant circuit I am drawing this as like this, 24.5, 10 and 12 volts. So 48 volts acting alone. So this is second source. So the current flowing from this source I am considering in this branch is I2 double dash. So already we have considered I1 dash, I2 dash and I3 dash. So next what you are doing, you are considering only 48 volts. So let us reframe that as I1 double dash, I2 double dash and I3 double dash. So because of this voltage source, I am considering the current flowing in this branch as I2 double dash. Current at this point is leaving, and in this branch I am considering as I1 double dash, and in this I3 double dash. So what will be I3 double dash? One current is entering and the other current is leaving. So I2 double dash minus I1 double dash gives you I3 double dash. So now what we have to do means we have to find out I1 double dash, I2 double dash and I3 double dash. So this circuit I am redrawing for simplification. So this resistor, whatever it is there, even if it is short circuit means it's simply a line. So I am considering this 24.5 ohms here, 12 ohms here, 10, and the source is 48 volts. Now first we'll find out I2 double dash. So I2 double dash, I equals to formula V by R. So here voltage is V2 divided by, how these two resistors are connected? They two are connected in parallel. So R1 R3 divided by R1 plus R3 plus the other remaining resistance is R1 R2, that is R2. I equals to V by R. So voltage divided by total resistance. Here these two resistors are connected in parallel. So R1 R3 divided by R1 plus R3. That combination, if you solve, you will get some resultant that will be in series with this R2. Now substitute all the values, you will get I2 double dash. So what is voltage? 48 divided by 24.5 into 12 divided by 24.5 into 12 plus 10. So if you solve this, you will get current as 2.65 amperes. Now similarly we will find out I1 double dash. So I1 double dash, where is that I1 double dash? The I1 double dash is flowing through 24.5, that is nothing but 24.5 ohm resistor. So we have to find out I1 double dash. So if you want to find out I1 double dash, you need to have at least voltage source here. So we do not have any voltage source. So already we got I2 double dash. So I2 double dash into so I2 double dash is the current flowing through 10 ohms. So I2 double dash into what you have to find? I1 double dash. So ఈ రెసిస్టెన్స్ లో కరెంట్ కనుక్కోవాలి కాబట్టి దాని ఆపోజిట్ రెసిస్టర్, దట్ ఈస్ వాట్ ఈస్ ద ఆపోజిట్ రెసిస్టెన్స్? దట్ ఈస్ R3 divided by R1 plus R3. Right? So now you have to find out, just simply substitute the values, that is 2.65 into opposite resistance is 12 divided by 24.5 plus 12. If you solve this, you will get some current as 0.871 amperes. Now you got I1 dash and I1 double dash and I2 double dash. Now find out I3 double dash. So what is I3 double dash? One current is entering and one current is leaving. So entering current is I2 double dash minus I1 double dash. If you solve that, you will get it as some value. That value you just write it down. So you got I3 dash also. So if you solve that, you got 1.717 amperes. So now you got I2 dash, I2 double dash, I1 double dash, I3 double dash. So in first step, what you got? I1 double dash, I2 double dash, I3 double dash. So whatever the currents are flowing, so here you can see when you consider single voltage, so 60 volts, you have represented as I1 dash, I2 dash and I3 dash. Similarly, now you considered 48 volts and you have represented the current as I1 double dash, I2 double dash and I3 double dash. So you found with 60 volts as I1 dash, I2 dash and I3 dash, with 48 volts as I1 double dash, I2 double dash and I3 double dash. So what is the resultant current flowing in this 24 ohms, 10 ohms and 12 ohms? So at first instant you got I1 dash, second instant I1 double dash, second instant I2 dash, I2 double dash, third instant I3 dash, I3 double dash. So you have to find out I1, I2 and I3. So for that you have to observe this figure. So in this figure, when you consider 60 volts, I1 dash is in this direction. Here it is opposite. So simply you have to find out I1 as I1 dash minus I1 double dash, because the directions are reverse. If both the directions are same, you have to add. So here I1 dash is in this direction. When you consider 48 volts, I1 double dash is in this direction. So simply substitute that I1 dash and I2 double dash and write down the solution. Simply next I2 equals to, so I2 is nothing but the current flowing in second branch. So when you consider 60 volts, what is I2 direction? It is in this way. And when you consider 48 volts, it is in this way. Both are reverse. So I2 dash minus I2 I2 dash minus I2 double dash. Similarly I3. So in both the figures I3 is flowing from B to E. Here also it is flowing from B to E. So both should be added. So I3 dash plus I3 double dash. So whatever the resultant you'll get, this will be the current flowing in each branch, I1, I2 and I3. Simply substitute those values and find out the answers of this all question marks, whichever it is being given. So this is how to solve the superposition theorem. So once you verify all the solutions whether they are right or wrong, so I have written some approximate value. Once you verify by substituting and calculate through the calci, and once verify the solution, don't blindly write these solutions. So if whatever the answer you get, you put that answer over here. If it is same, it's okay, leave it. If there is any mismatch in the values from my calculation and your calculation, simply you substitute in this formula, and whatever the values you are getting, you write it over here. So this is how to solve superposition theorem. Step by step, carefully you observe, you will understand easily. Thank you.